Hi, this is Tom Brower from the Hydrologic Engineering Center. This is the first video in a series of videos where I'm going to build a basic HEC-HMS model. In this video, I'm going to start by creating a project and then a basin model. As we go through the process, you should gain familiarity with HEC-HMS project components. Here are the list of steps that we will take to create our basin model. First, I'm going to create a new project. I just opened HEC-HMS. To create a new project, I'm going to go to the File menu and select New. In the Create a New Project dialog, I'm going to provide a name. I'm going to name my project Punks. And then I'm going to provide a location. I'm going to save my project to C Projects. And then I could optionally define a default unit system. I'm going to use US Customary. So now I'm just going to create that project. And now my project is created. If I browse to my project in File Explorer, you'll notice that it is a subdirectory on my computer. The subdirectory goes by the name of my project. If you want to share the project, you can zip the subdirectory and send it to others. It's important to keep data references internal to the project to keep the project portable. We recommend using the data subdirectory of the project to store data. If you zip a project with external data references and send it to a colleague, it's likely they won't have everything they need to interact with the project. The next step is to create a new basin model. To create a new basin model, I'm going to go to the Components menu and select Basin Model Manager. And the Basin Model Manager, I'm going to select New. And the Create a New Basin Model dialog, I'm going to provide a name. I'm going to name my basin Mahoning Creek. And then select Create to create the basin model. The basin model has now been created, and I can browse to it in the Watershed Explorer. Next, I'm going to add hydrologic elements to the basin model. The basin model gives the physical description of the watershed. There are 7 different subcomponents. First, subbasins. These are watershed catchments that capture rainfall over the land surface. Reaches. These represent rivers and streams. Reservoirs. These can be natural lakes or simply operated dams. Junctions. These provide a confluence of flow from 2 elements. You don't have to use junctions to bring flow together, but it gives you additional visualization options. In practice, we use them quite frequently. Diversions. These can model bifurcation and withdrawals. Sources. These can be springs or output from another upstream model. Finally, sinks. These can be outlets or terminal lakes. We can have as few or as many elements as we would like. We hook elements together in a way that represents the way water is flowing in our watershed. Most of the time, 1/3 of the elements are subbasins, 1/3 are reaches, and the remaining elements are a mix of reservoirs, diversions, and junctions. In my basin model, I'm going to use 3 subbasins, 2 junctions, and 1 reach to represent the watershed. So I'll start by adding my subbasins. I'm going to name the first one Mahoning Creek Local. The next I'm going to name Stump Creek. And then finally, I'm going to add East Branch Mahoning Creek. Next, I'll add my junctions. The first I'm going to name Big Run. And then my second junction, I'm going to name Mahoning Creek at Punks. Finally, I'll add my reach. And I'm going to name my reach Mahoning Creek. Now I'm going to connect my elements. You can do this graphically by selecting an element, right-click, connect downstream, and then selecting the element that you want to connect to. I can also connect by using the component editor. So in this case, I have Mahoning Creek local selected, and then I can select the downstream element as Mahoning Creek at Punks. When I click in the map, it'll refresh and draw the connection. Now I'm going to select my modeling methods. For my subbasins, I'm going to use the initial and constant loss method, the Snyder unit hydrograph transform method, and the recession baseflow method. To set the methods for all subbasins, I'm going to use the parameters menu. So I've just selected my basin model, and from the parameters menu, loss menu item, I can change the method. It looks like I already have the initial and constant method selected, so I'm good there. Now I'm going to take a look at my transform. It looks like the Clark unit hydrograph method is selected. I want to use Snyder, so I can change that here. So I've now changed all subbasins to use the Snyder method. Now I'm going to look at the baseflow. I said I wanted to use recession baseflow. It looks like that's already selected, so I'm good there. For my reach, I want to use the lag method. It looks like lag has already been selected for the reach, so we're good there. We've now selected all of our modeling methods. Now I'm going to parameterize my modeling methods. There are two ways to parameterize modeling methods in HEC-HMS. The first would be to select an element in the Watershed Explorer. Then in the component editor, I can parameterize things like area, loss, transform, and baseflow. If I'm parameterizing multiple elements at a time, I find it easiest to use the global parameter editors. To do this, I'll select the basin model in the Watershed Explorer. Then from the parameters menu, I have options to parameterize the different hydrologic processes in my model. I'll start with subbasin area. Next, I'll parameterize my loss method. One efficiency in the global parameter editors is to use the right-click fill option. I'll repeat the first value. Next, I'll parameterize my transform. And now I'm going to parameterize my baseflow method. Finally, I need to parameterize my reach. Since there's just one reach element, I'll select it in my basin map. And then in the component editor, I can specify the lag for my reach. My basin model is now parameterized. In this video, we created a new project. We then created a new basin model, added hydrologic elements to the basin model, selected modeling methods, and then parameterize the modeling methods. In the next video, I'm going to add precipitation gauges to my project and add a meteorologic model.